QDepSys
is a completely levitated electromagnetic, hydrokinetic, high-pressure propulsion power generating system. It produces clean, non-intermittent AC electric power 24 hours a day, 7 days a week, 365 days a year.
QDepSys
Does not alter the first and second laws of thermodynamics, and it is not a perpetual motion machine. It does not require fossil fuels to generate power. It does not emit pollution of any kind. It is a clean, green, and efficient source of energy. Its only fuel source is nitrogen gas, which is extremely cost-effective to produce. Its elegant design has few moving parts, keeping noise pollution to an absolute minimum, and it is engineered with low-maintenance materials like fiberglass, stainless steel, aluminum, and carbon fiber, making it completely corrosion-proof. The nitrogen gas tank and the hydraulic oil tank are pre-pressurized at the factory to 5,000 psi and 3,500 psi respectively to start and run the superconducting electromagnetic drive cylinder. Via control software, the system will monitor and control high-pressure hydraulic oil, cold nitrogen gas, high-pressure pipes, solenoid valves, filters, GPM flow, RPM speed, thermal heat, harmonics, generator torque, electrical performance, and others. Ultra-high energy nanotechnology capacitors will be pre-energized at the factory before the unit is transported and installed for residential, commercial, and industrial end users. An additional control system for high-pressure pipes and valves that distribute static and dynamic pressures of hydraulic oil and nitrogen gas to the piston drive pumps via high-pressure piping system delivers 5,000 psi of nitrogen gas and 3,000 psi of hydraulic oil to the upper and lower piston drive pumps. This is then pressurized on the outlet side to over 25,000 psi and higher if required to start, run, and cool the electromagnetic superconducting half-moon coils and magnets of the electromagnetic cylinder drive, the Pelton turbine, and the levitated electric generator motor. We inject high-pressure hydraulic fluid to the carbon fiber Pelton turbine. The high-pressure hydraulic oil is converted to mechanical power, thus increasing the RPM, speed, and torque to start and run a 1 megawatt generator. The hydraulic oil falls into an oil reservoir tank below the turbine, where it is siphoned by a smaller piston drive pump, a closed-loop system. At this point, the electromagnetic drive cylinder and the larger piston drive pump are disengaged by a magnetic clutch, and both devices fall into a neutral operating mode. By pressing the start button, a small amount of pressurized hydraulic oil is released at 5 psi from the pre-pressurized hydraulic oil tank. This activates 4 small horizontal hydraulic pistons connected to 2 electromagnetic superconducting coils within the half-moon plates. These in turn energize the superconducting magnets within the center cylinder drive to start and/or maintain power. As the 2 half-moon plates move towards the center cylinder drive, closing the central orbital air gap between themselves and the cylinder drive, they cause it to spin up to 5,000 plus RPM and generate as much as 4,500 Newton meters of torque. 2 vertically mounted pistons attached to the outer shell of the upper RF power amplifier superconducting coil stator are lowered to close the air gap between the upper coil plate and the lower superconducting magnet plate. These in turn are connected to the electromagnetic superconducting magnet center cylinder drive, thus electrically activating the cylinder drive magnets. This energizes both the superconducting electromagnetic coils within the 2 half-moon plates and the electromagnetic superconducting magnets, increasing speed, torque, and heat to 500 plus degrees Fahrenheit. This heat is managed by injecting cold nitrogen gas, which ensures system stability. The cold nitrogen gas is injected to the upper and lower superconducting coils via 4 Venturi nozzles to the cooling turbines. These are fastened to both the magnetic drive cylinder and the upper and lower alternator magnet plates. The upper RF alternator located atop of the cylinder drive is already spinning and electrically energized, shunting electrical power to the following areas: the half-moon plates, management software, electromagnetic gearbox, and the upper and lower piston drive pumps. The lower RF power alternator disc moves upward hydraulically, driven by 2 small hydraulic pistons, closing the air gap between the lower electromagnetic coil disc and the upper conducting magnet disc. In essence, a mirror image to the RF power alternator disc. However, this one powers the nanocapacitors, worm gears, solenoids, and the turbine jets. Via software control, the nanocapacitors are used for starting or furnishing power to other components when required and to supply power for 5 to 8 hours. An additional 12 high-pressure nitrogen gas carbon fiber tanks are furnished as backup power. The lower piston drive pump provides hydraulic pressure that will drive the levitated AC power generator. We inject nitrogen gas to the lower generator turbine via the hybrid cold injectors to cool the electromagnetic levitated bearings and magnetic winding stator. The nitrogen gas can also assist in starting cycles if and when required by the control software. The second electromagnetic superconducting coil gearbox is mechanically connected to the bottom of the Peloton turbine shaft via an electromagnetic slip clutch to prevent RPM speed and torque overload to the electric generator. At this point, the generator is now running at full capacity at 220 or 448 AC volts, 60 Hz, producing clean, non-intermittent AC power all 8,760 hours of the year. After the first 8,000 hours of service, the machine is shut down for 3 hours to do full maintenance checkup and collect historical data. The machine can be adapted to work anywhere in the world.